Okay. Hello everyone. Welcome to session 3 for day 2 in PyCon Indonesia 2021. My name is Kartika and I will be the moderator for this session. Okay, I would like to introduce our co-speaker right now in this session. He is Kalyan Prasad. Hello, Kalyan.
Hello everyone. Hi Kartika.
Okay. Hi. Okay. So Kalyan Prasad is a data scientist and analytics manager at Creative Cruise. And in this session, he will share an interesting topic. He will talk about decision tree visualization. And for all audience, if you have any questions regarding this talk, you can keep those questions coming on Hubilo platform in the chat box. So the moderator's team will collect it and we will discuss it in Q&A session. All right, so without further ado, Kalian, the stage is yours.
Okay, so do you see my screen? Can you confirm can you see my screen, please?
Yes, Kalian, your screen is shown on the screen.
It's visible, right?
Yes, decision tree visualization.
Yep. Thank you.
Yes.
Yeah. So hey, hi folks. It's an honor given to speak to you all today at PyCon Indonesia, and I'm super excited to speak to you all, and thank you for joining my talk from wherever location you have been doing and what time zone you have been attending. So I really appreciate your time and yeah. So some cheap marketing. I'm Kalyan Prasad, and I'm a self-taught data scientist and analytics manager. And I'm a community first person, so I love being involved with different communities. So I've been helping different communities, and I try to help with those communities as much as I can. And currently, I'm associated with this organizations called PyCon India, PyCon Hyderabad Python User Group, and Humans for AI, where I have a different roles and responsibilities in all of these organizations. And one of the good thing is I always love to give back to community. So I always look for an opportunities to share my knowledge in multiple ways. Yeah, that's pretty much about me. And so here is the agenda for today's talk. So we'll start understanding what decision trees are, and we'll also look at the types of decision trees we have, and some of the key elements which are involved in decision trees. We'll see that as well, and we'll touch upon widely trivial library, and we'll then finally we'll jump into the action to see some cool data visualizations on decision trees, and then I'll conclude my talk accordingly. So feel free to drop your questions or anything. Yeah, I'll address each and every point after the session. So yeah, without any further delay, let me get started. So, so in machine learning era, we have so many fancy algorithms that gives more accurate predictions. But when it comes to decision trees, they are very easy to understand and they are pretty straightforward. And you don't need much mathematical knowledge in order to understand the logic behind decision trees. It is one of the easiest algorithms in machine learning. So a decision tree uses a tree-like representation or a structure or a design to get actual inferences. So a decision tree is one of the simple and intuitive techniques in machine learning based on the divide and conquer paradigm, meaning that decision trees are constructed via algorithmic approach that identifies a ways to split the data based on different conditions. Now, the idea behind decision trees is to partition the spaces into patches and to fit a model to a patch. In a simple terms, the goal of the decision tree is to create a training model that can be used to predict the value of a target variable by learning a simple decision rules inferred from the data aggregates, which is nothing but the training data. Of course, decision trees are building blocks of many advanced algorithms. For example, random forest and XGBoost, the two most popular algorithms in machine learning for structured data. And finally, decision trees are also family of supervised learning algorithms. So unlike other supervised learning algorithms, decision trees can be used to solve both classification and regression problems as well. Now, the types of decision trees are based on the types of a target variable we have. So it can be a regression decision tree or it can be a classification decision tree. So how do I identify which type of a target variable we are dealing with the data? So, so the decision tree which has a continuous target variable, then it is called as a continuous or a regression decision tree. For example, predicting the house price, which is a continuous target variable. And when it comes to classification, the decision tree which has a categorical target variable, then it is called as a categorical or a classification decision trees. For example, predicting risky loan applications from the entire loan application. So so this is how we deal this is how we identify and deal with the target variable when we are working on the decision trees, and this is how we identify and we do our analysis. Now, in order to familiarize with the decision trees, we need to understand the key elements involved in decision trees. We can also call it as a structure, or you can also say it as a flow chart of a decision trees. So it has been primarily classified into three parts. The first one is a root node, and the second one is a terminal node or a leaf nodes, and finally it's a branches. So we'll try to understand all these key elements by looking at this visual. So the very top of the tree is called a root node. So this is a root node here, and then we have it's called a splitting. So it is a process of dividing the nodes into two or more subnodes. So this process is called a splitting. Then we have a decision node. So when the subnodes divides into further subnode is called a decision node. So if you see here, the subnode has been divided into further subnode. So this is called decision nodes. Nodes that do not have any splits is called as a leaf node or a terminal node. So this is a terminal or leaf node because we do not have any splits after the terminal node. So this is the final node for the tree. So this is called a terminal node. Then we have a branches. So the entire subsection of a decision tree is called as a branches. So this is a subsection of entire decision tree. And finally, we have a parent and child node. So when a node is divided into subnode, then it is called as a parent node of a subnode, whereas subnodes are a child of a parent node. For example, in our case, A is a parent node and B and C are child nodes in this case. So let's look at some real-time example to understand how the decision tree process works in a real time. So here is a problem statement we have that a person who has a job offer and whether he wants to accept that particular offer or not. So to solve this problem, we'll start with a root node here. So the root node here is a salary which is between the 5,000 to 8,000 range, and this root node further splits into a decision node and one leaf node based on its corresponding labels. So the decision node here is the distance, whether the office is near to my place or not. So based on this decision node, so we'll take a decision, and then this decision node further splits into another decision node and one leaf node, which is again the providing cab facility. So whether they are providing a transport facility or not. So based on this, then finally this decision node splits into two leaf nodes, whether to accept the offer or decline the offer. I mean, these are like pretty crazy requirements here because we have a very good salary here, and person is also when they are also providing that the distance is also very near to my place, and I'm also cross checking whether they are also providing a cab facility or not. So these are very crazy requirements, and definitely if I'm in that particular case, I'll definitely accept an offer because the distance is also quite near to my home. They are also providing capacity. I'm also getting a good monetary figure of salary here. So why do I decline? Definitely I'll accept this offer instead of declining. Okay, so coming back to our main point. So this is exactly how we create a decision tree structure for any data science problem in real time. So this is exactly how the process works for any decision tree problem in a real time. So I hope you got a fair understanding about the decision trees and its structure, how it works in a real time. So now let's jump into our next section, which is called why D-trees. So before I actually talk about the D-trees library, let me tell you some of the pain points or issues which are existing in the current visualization packages. So I'll address those points first, then we'll talk about the D-trees stuff later. So, as always, it is rightly said that a picture is worth of 1,000 words. So, this principle is equally applicable for machine learning models as well, because if one can easily interpret the results, it inculcates more confidence in the model predictions. Right, makes sense, right? So, now visualizing a decision trees is a tremendous aid when learning how this model works and when interpreting these models. Unfortunately, our current visualization packages are not immediately helpful to the novice. For example, we do not have any library that visualizes how decision node is split up at feature space. Of course, scikit-learn inherently has a plotting capabilities for decision trees via sklearn.tree.export graphics function, but it still has some potential issues. So, I mean, a couple of problems in our current visualization packages. So, do we have any alternative to solve these problems? So, this is where the dtreeviz library comes into the picture to solve all these problems. So, you'll see all this stuff when we move on to hands-on part. For the moment, just follow the flow now. Now, now it's time for dtreeviz. So first thing first, so it's a Python library for decision tree visualization and model interpretation. And this library currently supports scikit-learn, XGBoost, Spark, mlib, and lightgbvm trees. The best part of dtreeviz library is not only creating a beautiful visuals, but also conveying more information about the decision tree process. To remember this point, trust me. By the end of this talk, you will definitely agree with this statement, and I'll also justify this statement practically, or I'll justify this statement by my end of the talk, and will show you practically on this point. And with dtreeviz library, we can also visualize how feature space is split up at decision nodes, and how training samples get distributed in leaf nodes, and how the tree uses predictions for a specific observations, and many more. You will see all of these things lively in our hands-on session. So far, I think I have given enough download or a GAN on theoretical part of a decision tree and retrieval library. So let's straight away jump into some action to see how we can visualize a decision tree, and how we'll gain the insight from it. So let's see that. So let me quickly jump to my code notebook. So yeah, so here is a notebook which I have created for this demonstration. So so the goal in this notebook, so I'll show you the different ways of visualizing decision trees, and I'll also show you the power of a dtreeviz library in this notebook. So installed a couple of libraries here, which is py.plus, which shows a Python interface to a graphics.image, and graphics library. With this library, we can visualize the decision trees and interpret the results. And of course, with dtreeviz also, we can visualize the decision trees and interpret the results much better comparatively with the graphics, which you will see them in a while now. So, so as usual, I've imported necessary suspects here. So a couple of libraries, and from sklearn, I'm importing data sets. So for this demonstration purpose, I'm taking two data sets from sklearn, one for a classification case and other for one for a regression case. So just let me load my libraries now. So okay, I have loaded the libraries. So we'll start seeing the classification case first, then followed by regression, and finally I'll show you some of the customization which are involved in dtreeviz library. So yeah, so for classification case, I'm taking the wine dataset from sklearn dataset. So I've loaded the data here, and I've initiated my x and y variables, and then I'm initiating my classifier here, and also with default parameters. So I'm not passing any other parameters here. I'm just going with the default parameters here, and I'm just fitting the classifier. So so from this data set, our goal is to predict the best class of a wine from different classes. So there are different classes of wine existing in this data set. So we are predicting the best class from this data set. And before moving further, I would like to mention one important point here is, since the goal of our talk and this notebook is to show you purely on a visualization part, so purely visualization part on decision tree. So I'll not talk anything about model building or model accuracy or even hyperparameter tuning, etc., because which goes beyond the scope of this talk. So I'll strictly show you about the visualization part. So I hope you are clear with the objective. We have the objective now. So, so we'll start seeing the traditional way of visualizing decision tree. So there are multiple ways to do that. So we'll see those things one by one now. Okay. So the first one is a text representation. So it builds a text report showing the rules of a decision tree. So this is again pretty simple here. So I've created a variable called text representation where I'm calling my tree dot export underscore text function and passing an instance called classification. So it's up to you which instance you want to pass. You can pass classification or regression. So it's up to you. You can choose it. Since we have started our explanation with the classification case, so I have passed my classification instance here. So once I print this, so there you got a no textual representation of a decision tree flow structure. And if you observe this structure, we got a futures here, and we can also see the values that are rounded up to two figures, and we can also see the class, which are the number of samples, class weights, which are the number of samples in each class. So that's pretty cool, right? And this feature is especially useful when you are working on application without user interface or when you want to log information about the model into a text file. So this is where this feature helps us in real time. So next, another way of visualizing a decision tree is with the plot underscore trees function from sklearn. So with this, we can visualize the result and visualize the decision trees and interpret the results. So let's see that as well. So I'm calling my tree dot plot underscore tree function and passing my classification instance and also a couple of parameters here, which is called feature names, which is nothing but the name of each of the features available in the dataset, and class name is nothing but the name of each of the target class, which will show you in the ascending order. And field equals to true means this method showcase with the colors to highlight the majority of the classes. So fill true highlights the majority of the classes in the visual, and rounded equals to true, which means that I want my figures to be rounded in rounded figures. So once I execute this code, so we'll get image. So there we got a the big decision tree on our wine data set. So the reason behind for this big data, the reason behind for this big structure, the reason behind for this big structure is that we haven't restricted our tree size here. I mean, like we didn't pass any magic parameter in our classification when we are initializing the classification. That is the reason why we got the entire tree structure on our wine data set. So this looks a bit good on decision tree structure, but the problem is it is very hard to understand what this visual is conveying. I mean, like it is quite hard to read or understand what exactly this decision tree is conveying the information. So in this case, what we can do is we can scale this image much better with like this library called GraphViz. So this is with GraphViz, we can also visualize the decision tree much better comparatively with what we have seen in the plot tree. So let's see that as well now. So I've initiated the string.io and calling my tree.export.graphics function, passing my classification instance and also the same parameters which you have seen above. So then I want my image to be in a graphics.image, and then finally I'm converting that image to a PNG file. So once I execute this, okay, so there we got a no very clear and comprehensive picture. I mean, comparatively with this one. So it is very similar with same set of elements what we have seen in both. So the elements, everything remains the same, but the only thing is it shows a very clear picture comparatively with that one. So let's try to understand this visual and what are the problems involved in this decision tree. So if you observe this visual, it is immediately not clear that what actually these colors, different colors represents, and there are no labels for target class as well. And it includes Gini coefficient for certain cost space, and it does not help with the interpretation as well. And we can see the number of samples in this visual, but it is not easy to visualize the distribution here. So this is where the histograms helps us. And if you also observe that size of each decision node remains the same irrespective of the number of samples. For example, if you see here, the sample here is a 1.1 percentage, and here the sample is a 3.4 percentage. So the both decision node size look the same. So there is no much difference here. So these are a couple of problems in this visualization. So in order to address all these problems, so this is where our dtree library helps in and to solve all these problems. So this is exactly what I was talking earlier in my slide. So I hope you got this point now. So let's see how dtree solves all this problem. And shows conveys much better decision tree process information. So far, whatever we have seen are the traditional way of visualizing decision trees. Now we'll see stuff in dtree style. So this is pretty straightforward, and the code is also very similar with what we have seen above. So I'm calling my created variable called viz and calling my dtree function, passing my classification instance, also the same parameters what we have seen above. The only new parameters here are the func equals to true, his type, which is nothing but I want my histograms to be in a stacked bar chart, and then I want and then passing a parameter called scale, and then I'm giving a title here. So once so for the moment for the timing, you just remember these two parameters called fancy and scale. So I'll talk about these parameters in some time, but for the moment you just follow me with the flow. So once I execute this, okay, but I see some error. Okay, it's a font. Okay, let me try to rerun it. Cool. So see, this is how we got a full visualization on our wine data set classification. Let's try to understand how this visualization conveys decision process information and how it is different from how this addresses issue which we have seen above. So if you observe this visual, at each node, we can see the stacked histograms of the feature that is used for splitting the observation segregated by a class. So histograms were the feature that were used for splitting the observations segregated by a class. So by this, we can see that how each class are segregated at each split. So if you observe from root node, see how it is splitting the observations. And if you also notice the black triangle with the value at the x-axis, it shows the splitting point. So this is exactly the splitting point here. And the black triangle, it shows a very clear thing here. And we can also see the class one of the samples that are clustered at this proline feature space. So these are the class one samples that are clustered at this proline feature space. And if you also move to the leaf nodes, which are represented as a pie chart, which indicate that what proportion of observation within each leaf belongs to which class. So if you see here, this pie chart, and by this we can also see the majority class and also the model prediction. So in this case, class one is the majority class, and this is our model prediction. So the only thing which is missing in this visual is the Gini coefficient for each node. But however, our histograms provide more intuition about our split process. So I guess the coefficient value is not required in this case. So it is like very good, pretty cool visual, and which you can easily convey the information to your stakeholders. So if you visually compare these two visuals, this visual conveys much and clear information about the decision tree process information comparatively with this one. And so it is very easy to explain this decision tree process to your stakeholders comparatively with this one. So this is the power of dtrivs library. So with this, we have finished our demonstration on a classification case. Now let's jump into the regression one. So if you want to save this image, or if you want to use this in further future purpose, so you can simply save by using the wiz.save, and it will automatically get saved in your code, and you can use them in a separate. So it will save here, and you can use it for your future purpose. So when it comes to regression, so visualizing regression is same as what we have done in classification. So except the only thing is we need to change the target name here. So for regression, I'm taking the Boston housing data set from sklearn. So I've loaded my data here and initiated my x and y variables. And now I'm fitting my regressor. I initiated my regressor. So instead of a default parameter, this time I'm restricting my tree size by giving max depth is equal to 3 parameter, and then I'm fitting my regressor. So the goal from this data set is to predict the median housing prices in certain areas of Boston. So this is what we are predicting from this data set. And so let me load this one. Okay, I got some error here. Okay, okay, so okay, this is quite a new error. Okay. Okay, so this is about some data set issue. Okay, okay, so I'll figure it out later. But okay, for now, we'll just proceed with our demonstration. So I'll look into it. There's a new error which I've encountered. I'll see that. Okay. Uh, so so we can also do the same traditional ways of traditional approach of visualizing what we have done on classification. The same thing we can also do for regression as well. But I don't want to repeat and explain the same process again and again, because everything remains the same. The only thing we just need to change the instance of the class or the instance there. So definitely you can give it a try and explore it, but I'll straight away jump into the dtrivial style and show you how it works in regression case as well. So I'm calling my dtrivial function and pass my regression instance here, and rest all the parameters remain the same. There is no difference here. So once I execute this, and yeah, so there we got our decision tree on Boston dataset regression. So let's also try to understand this decision tree and what are the insights we gain from this visual. So in classification, we looked at the stacked histogram, the feature that were used for fitting the observation. But when it comes to regression, we'll see the scatter plots of the feature that were used for fitting the observation. The scatter plots are the feature that were used for fitting the observation in this case. And if you also observe this graph, we can see the dashed lines on our scatter plot. So what are those? So the horizontal dashed line indicates the target mean from left to right buckets in the decision nodes, and the vertical dashed line indicates the splitting point here, and the black wedge at the end here is it shows the splitting point, and it also identifies the exact splitting value here. So if you see here, so this is the exact splitting value which is highlighting here. And if you move to leaf nodes, we can also see the dashed line that shows the mean of the target within leaf, which is also called as a model prediction here. So this is how we gain insight from these visuals, and with these visuals, we can build better models and improve our business, because it is showing a clear path that because this visual is conveying a clear path that how what are the predictions are coming, and based on this visual we can build a better models and we can improve our business much better. So with this, we have also finished the demonstration on regression. Then we will see about the customization. So the best part of a dtrivial library is it offers a bunch of customization. So I have covered a couple of them here. So we'll see one by one them as well. Scaling the image. So as I mentioned earlier that I'll be talking about the scaling parameter. So it's the time now. So the scaling parameter can be used to scale the overall image. So we just need to pass the scale parameter, and you need to give the value that how you want to see your image. So in this case, I've given a 0.5 value. So the rest all code remains the same. So I've initiated my data, loaded my data, and just plotting my data. So this looks a very crisp, short, and clear picture. So it's again up to you that how you want to scale image. So if you want to see in a small size, you just need to reduce the value in the scale parameter, or if you want to see in a much larger and bigger way, so just need increase the value and you'll see the image better. So it's up to you that how you want to scale your image according to your requirements. So next we have is the colors. So colors play a very key role in the data visualization because it throws a lot of insights from the visual. So when it comes to deep reviews, so we have an optional parameter of a colors where we can pass a dictionary of colors that is to be used in the plot. So I'm just passing the same thing here. I'm passing a dictionary of colors, and what I want here from this colors here, I want all my scattered dots to be in a green color. So let me plot this and show you. Okay. So what's the error here? Okay, let me rerun it. Should come. Okay. Type. Okay. It should come now. I'm not sure why it is not coming. Everything remains cool here. Okay. So I'll check this one as well. I mean, like for the moment. So we'll cover this point at the end of the thing, and let me cover the rest thing because we have a limited time here. So so next one we have is a show node labels. So we can turn on node labels on our decision node. So this can be done by passing a labels called show node labels is equal to true parameter. So I have done this. So once let me execute this. Why these things are happening? Uh, just let me load this everything. Just give me a second and let me run all. Sorry for the inconvenience. I mean, like, I don't know, something went wrong in my notebook. Okay, seems like there's an issue with the. Hmm, okay, let me rerun it. Sorry. Seems like I think the issue with data sets, so it has some ethical issues here. So I think that's the reason. I mean, like, so that is the reason I guess it is not working now. Because I see a warning message on the data set. I mean, so just a minute, it should work here. Uh, okay. Oh my goodness. Yeah, should work now. Okay. So yeah. So this is how you see the node labels on the decision nodes, and this process is especially useful when you are explaining the information to your stakeholders. So you can simply highlight or mention the split point by highlighting the node number. So see how cool it is the same way. And also, and simple graph without histogram and scatter plot for decision node. So which means that we'll not see any histogram or scatter plot. We'll see a simple plain decision tree here. So in this case, so we can achieve this by passing a parameter called fans equals to false. and you'll see that. So this is a plain decision tree you'll see, and also highlighting the class colors here. And so personally, I'm not a huge fan of looking the decision tree in this way, because I like to see histograms or a scatter plot, because that helps me to understand that decision tree and also gain much insights from that rather than this one. So it's again up to the nature of interest. So how if some people folks like this way, so they can use this way of visualizing their decision tree. And next is a tree with a left to right alignment. And so the so by default the orientation parameter of tree will be a top to bottom, but you can also change the orientation from left to right. So simply by simply passing a parameter called orientation left to right. And so this is what you have done, and now you see the orientation has been moved from left to right. So again, it's depends upon the nature of interest. So how you want to see, if you want to see left to right, you can definitely use this parameter, and you can see your decision tree process. And next we have a prediction path of a single observation. So this helps us to understand which decision path is followed by a specific test observation. So what I'm doing is, in our case, so I'm taking a random sample from our data set and it transfers it to decision path now. So once I execute this, and so there we got a visual here, and let's try to understand this visual now. So we, by looking at this visual, the orange color clearly highlights the path which the observation is followed. So you can see the orange color which clearly highlights the path which is followed by the observation. And we can also look at the orange triangle, and I'm sure you have been able to see. So we can also see the orange triangle at each of the histogram, which represents the observation value of each feature. And finally, we can also see the value of the feature, that the ones used for highlighting the decision in orange color. So for example, here magnesium, flavins, and prolines, these were the three features that were used to predict belongs to class 0. So the class, in order to predict the class 0, these three features were used for predicting this one, and it is also highlighted in orange color. See how amazing it is if you want to predict a particular path observation. See how cool it is, right? And next we have is the only path. So if you so earlier we have seen that prediction path for a particular observation. So in this case, if you want to see only path, I mean like only the decision nodes which are used for prediction, so you can also do that. So again, I'm taking a random sample from my data set and transferring its decision path now. And so once I execute this, so we'll get only the decision node that were used for prediction. So these were the decision nodes that were used for predicting the class 1 here. So since it is a random, so I picked the random sample. So that is the reason we got a random prediction here. So it's again, if you are focusing on a particular thing, you will get a very accurate prediction. So since I'm generating a random stuff here, so that is the reason I got a random prediction here. So these were the nodes, like prolane, favens, and also these were the features that were used for predicting the class 1 here. Cool. Next we have is a prediction path in plain English. So this is again a very simple single line of code where I'm calling explain prediction path function, where I'm passing my classification instance, X factor, future names, expression type in plain English. And once I execute this, so there we get the prediction path in a plain English. And this is especially useful when you are explaining the decision tree prediction process to the non-technical folks, or even for the folks who don't have a ML knowledge. So for them, it is very easy to understand that what were the prediction paths that were used for predicting. So this is where this feature helps them. And finally, we have is the future importance. So we can also predict the future importance in decision trees, but in D-trees, we can also visualize the features that were involved in top decision tree prediction. So what I'm doing is I'm calling again, this is again a single line of code where I'm calling my prediction path function, passing my class instance, X factor, feature names, and explanation type is equal to scikit-learn. I think so. So there we got a feature. So if you look at this graph, so the RM, CRIM, and else 60, 80 are these were the futures that were involved in for predicting the boson house prediction. So these were the top features that were involved in for the boson size prediction. So see how this cool customization helps us to know predict the different things in decision trees, and how can we identify how it helps us to identify different things in decision tree process. So this is the power of D-Tree's library. So to summarize the things, so we have seen the traditional ways of visualizing decision trees, and we have seen the issues which are existing in the current visualization packages, and so how we have addressed those issues with the D3V's library. And we have also seen that how D3V's library creates a beautiful insights and conveys information about the decision trees, and how those information can be how from those visuals how we can convey the information to our stakeholders, or even for the folks who are less technical knowledge. So we have seen all of these things. So it's a pretty cool library. I mean, like pretty cool. I think you can definitely use as a maybe you can definitely use as your go-to tool for your decision trees. So on a final note, I can say that there is so much more you can do and explore with a D3V's library, but I believe this is plenty that you can get started. And yeah, with this I finished my hands-on part, and let me quickly move back to my slides. And so, yeah, here are the references if you want to explore on D3V's library, the documentation page, GitHub, and stuff, etc. And yeah, thank you. And if you have any feedback, questions, or any suggestions, so for me, so feel free to connect me on my social media platforms. On this platform, I'll be happy to connect and chat with you all. And yeah, thank you so much.
Okay, thank you so much, Kalian, for the talk. It's really interesting topic, I think. And in this stage, we are opening some Q&A session. There is some questions from the audience. I will show the first question. Okay, this is question from Bima Priyambodo. Hi, Kailan, so interesting. Just curious if in business cases, what actually the added value from visualize the algorithm, whether this function to avoiding black box problem?
Sorry, I'm unclear. I'm not able to catch up the question. What exactly the point is? If in a business case,
I
what
think
actually the added value
kind
from
of
business?
business cases.
How added value? Okay, what actually the added value from visualize algorithm? It is one. I mean, there are so many things mixed up in this question. I mean, like so, so see, one thing is visualization definitely helps the added value of the business, because you cannot everything monitor by looking at the data, right? So you cannot, there are tons of data, or else when you have a huge data, it is very difficult to identify. So what kind of issues it is, then until unless you do the visualization, and so this is where the visualization helps us to uh, show you show us some insight. So based on this visualization, we can build better models, not only for decision trees or for any data analysis stuff or any data mining you're doing it. So visualization always helps us. It shows us some path to build some better models. So it's excellent. So always a visualization is always a good thing in order to build a better model. So yeah, that's how it adds a value. But whether this function to avoid black box problem, so I am quite skeptical on this point on the black box problem. Again, I'm not sure on this thing. Yeah,
Okay, maybe we can move to the next question, Kalian.
yeah.
Okay, this is the question from Latif Al Rashid. First of all, I'm very new in this topic. Why in this, the classification case the fish use histogram, but in the regression use scatter plot? Is there any specific purpose?
There was no specific purpose. This is how, I mean, like they designed the things. I mean, when the author has developed the library, this is how they designed it. I think there was no specific reason. I mean, I guess so. There is no specific reason on that for the classification. So yeah,
Okay, so there's actually there's no specific purpose whether we can use histogram or scatter plot.
yeah. I mean, like when it comes to DTV's library, this is how it was designed. I mean, like for classification purposes, we can see the stacker histogram feature, so that's how it helps us to understand how the splits were happened. Maybe I'm not sure whether we can also use it because I never experimented on other plots of classification. Maybe I should also give it a try. But as far as I know, that no, there was no specific reason behind these things.
Okay, all right. I think that's the last question. So there are only two questions right here. So I think this is the end of this session, Kalian. So again, thank you so much, Kalian, for the talk, and thank you so much for all the participants who participate in this session. Unfortunately, we ran out of time too. So if you want to discuss more about this talk, you might join to the room. Ask the speaker on this. Oh, I see that. There's a question. Is it okay, Kalian?
Yep. Please go ahead, please. No
Yes.
problem.
Okay. There's a question again. I will show to you. Okay. Wait. Okay, this is the question from Muhammad Adam. Hi, would you like to share some of your experience in handling a multiple cases using decision tree?
Mm,
Multiple cases.
so so multiple in case so far what I've experimented, I mean, like what I have done in my profession or real time is more on a regression and classification cases. So I have never explored beyond. Maybe you can also do some ensembling techniques on decision trees. But those are very bit high level. But personally, as far as my experiences, because uh, the reason is like this simple stuff will give you more accurate predictions. As I mentioned earlier, also, so there are so many fancy algorithms that give more accurate predictions, but decision tree is very easy, and also it gives a better predictions in real time. That is the reason why decision trees are used globally in machine learning area for any data science problems. So, according to my experience, so most of the cases which I handled was either a classification or regression. So I didn't went beyond classification or regression in my personal experience and in my real time experience. But you can definitely expand the different techniques of ensembling and other stuff on the CFDs. Yeah.
Okay. Okay. Yes. Thank you so much, Kalian. I think that's really a last question from the audience. And thank you again for the participant who participate in this session. Again, if you have any question or something to discuss, you can join this room. Ask the speakers for PyCon Podium 1. And if you want to give some kind words to our speaker, you can send it to this link. Okay, again, thank you so much. And I think this is the end of the session. So allow me to close and see you soon in other session.
Yeah. And thank you so much for having me at PyCon Indonesia. It was a really
Yes.
great time. I had. See you all. Take care.
See you.